Hello viewers, welcome to Let's See It. Today in this video we will be discussing about cache memory. In the previous video I have discussed the memory hierarchy. There we have seen after register the next fast memory access is cache memory. So what is this cache memory and how it works? It is a microprocessor. This is a processor. Okay, it is a processor. It wants to fetch or read some data from memory, and this is a main memory. It will obviously read from main memory. It is a main memory. It sends a fetch request signal. Okay, it sends a fetch request signal, and in response to that, if that data is present, then main memory will send a fetch acknowledgement signal, right? And the time between this is res, fetch acknowledgement signal, minus req. Now as main memory is slow, in the memory hierarchy you have seen, this is a memory hierarchy. At first there is flip flop, then register, then we have cache memory, then we have main memory. So cache memory is faster than main memory. So by the time the main memory sends the acknowledgement signal, that is the data is present, the time is very slow. So the processor will be sitting idle. So we place a cache memory in between the processor and main memory, so that before before accessing the main memory, the processor will first send a request to the cache memory to see if that block is present in that cache memory or not. If that block is present in the cache memory, then the processor will send a uh, acknowledgement signal. Cache memory will send an acknowledgement signal to the processor, right? This is an acknowledgement signal and this is a request signal to the cache memory. So doing this, we get to see the cache memory access time by the processor, which is rs minus re. Here ta is much greater than ca. That means if the block is present in the cache memory, we can access that or get that by the processor in a much faster time than we get in the main memory, as cache memory is much faster in the memory hierarchy than main memory. Now for this to happen, uh, the content of the main memory must be present in the cache memory. So the frequently accessed content is localized or copied into the cache memory, so that the frequently accessed data, so that before going to the main memory, before the processor access the main memory, it first access the cache memory, and if that finds it, the time of that access time will be much less. So we localize the content from main memory to cache memory. This localize a copy, bringing the copy of data from main memory to cache memory is called locality of reference, right? So now we have seen we want to localize the data from main memory to cache memory to be accessed by the processor. Now if the processor first access the approach the cache memory and say are you carrying the data or not. If the data is present there, then we call it cache hit. If the data is present, if the data is present, then we call it cache hit. If the processor doesn't find the data in the cache memory, we call it cache miss. Absent. Data is absent, right? Now what will be the total attempt? What will be the total attempt? Total attempt means how many times the processor approaches the cache memory. How many times? This will be cache hit plus cache miss. That means total attempt is equal to cache hit plus cache miss. That many times the processor approached the cache memory to find the particular data or set of blocks. Now, what would be the performance of the cache memory? Suppose heat ratio. How to find the heat ratio? Heat ratio of cache memory. That means how many times the content which need to be accessed by the processor is found in the cache memory. That is the heat ratio. Is cache heat by total number of attempts. Total number of attempts. Cache hit by total number of attempts. And now what will be the total miss ratio? That means miss ratio. What will be the total miss ratio? It will be catch miss by total number of attempts. Quite easy. That means the number of times the processor didn't find the content in the cache memory, then the processor will have to approach the main memory for that content, right? If not found in the cache memory. Okay, this is the heat ratio and heat ratio and miss ratio. Now, as our cache memory lines are limited than the main memory, as we know, main memory is much bigger in the storage capacity. In the memory hierarchy we have seen, cache memory is higher in a hierarchy and main memory is lower in hierarchy. That means the storage in main memory is much higher than the cache memory. So we have a limited number of lines. In cache memory, but much greater line in main memory, right? This is the main memory and cache memory. We have a limited number of lines in cache memory, but many compared to the cache memory in the main memory lines. Now we have to bring the set of blocks to the cache memory, from main memory to cache memory. So we have to use some techniques to copy data from main memory to cache memory using some techniques, because we have a limited number of lines in here. So there are three mapping techniques by which we can map the contents of main memory to the cache memory. Three mapping techniques. Number one is direct mapping. It is another one is associative mapping. And another one is set associative mapping. These are the three mapping techniques we use to map contents of main memory from contents of main memory to cache memory. Okay, now we during the use of cache memory we face a problem called cache coherence. Okay, that will be discussed in the next video. Stay tuned. If this video is helpful to you, please don't forget to like, share and subscribe my channel and press the bell icon to get further notification of my next video. Thank you.